So in the last video, we just got a sneak peek at how TypeScript basically works. But let's just start from the basics here, and let's just talk about how data types are created here. So first of all, there's a little bit of difference in notation here. In C-like languages, C++, Java, and kind of languages, you write something like you have the name of the class, say students2 equal to new student. Something like that. You write here, we write in a very different way. We write like this. Say I want to create a number. Instead of writing something like number x equal to 10, we write let x colon number equal to 10. Okay, so the data type is going to come after the variable instead of before the variable. This is generally called Pascal-like notation, because the Pascal language used to have this kind of notation. Some languages like C# and Kotlin and also have this kind of notation, very similar to this. What we can do is also actually not give a data type here. Let x number and just end the line there, and then somewhere later we can do x equal to 10 like this, and we can write x equal to 11. But if I try to write x equal to some string, and I start getting an error here because I cannot assign data type of something of not of a type number into x. Okay, so what are the data types that we do have is that we can do let y equal to string, sorry, let y string. Numbers are like this. Yep, let me just try that out. String data type. So all the basic primitive data types that JavaScript has, they are available. Like this Boolean data type, which we can set as say false, some value like this, and we can set the object data type. If we set an object data type, we can create a variable like this, and then we can have finally, I think we can have a symbol data type. There's a primitive data type called symbol. Apart from that, now we can also have complex data types, and complex data types are like this. If I set let x, oh, I think I've used, let me use c, let c equal to, and I write a10, b20, like this. Sorry. And if I write c dot a equal to something like 90, I change this value, it's fine. If I do c dot b equal to some string, I start getting an error because it can understand the data types of the keys inside an object as well. So the data type of c dot b is number, because I have set it as number right here. Okay. Now, if I try to do something like c dot d equal to some string, I'm going to start having errors here as well, because the variable d does not exist inside C. So it has understood that C is not just any object. C is an object which has only two variables inside it, A and B. So if I try to set something like D inside that, it's going to complain about it. Okay, so TypeScript does not only understand the simple data types like number, string, boolean, object, like that. It can also understand the complex data type, as in the shape of the object. So if I create C like this, it can understand that C has only A and B keys inside that. Okay. We can also set up data types in the variables that are coming inside a function. So if I create a function, say add, and I write like a comma b, and I do return a plus b here. Okay, and if I write x equal to add 5,6, okay, and you see we don't have a problem here. But if I write x equal to add a comma b, now you see that this is something that in a language like Java or C++ would have stopped us from doing it, because if I add A and B as strings, then the value that I'm going to get returned from the function is also going to be a string. It's going to concat the letter A and the letter B, give me a string AB, and X was of data type number, so I should not be able to add a string here. Okay, so this is where we can now set the data type of the arguments in a function, and we can set the data types of the return type of a function. So let me say that this add function takes only numbers, right? So now you see it starts giving me an error that parameter argument of type A is not assignable to parameter of type number, right? So I can only pass like numbers here. If I try to pass a say null here, okay, that works because I'm not passing anything. But if I try to pass a string here, it's gonna give me an error. If I try to like not pass the second variable, it still gives me an error because I need to pass two variables, but I've only passed one of them. Okay, so now this starts looking a lot more like the kind of functions that we have been using in more strictly typed languages like C++, Java, C#, and so on. So the function starts enforcing its rules. Now, maybe I don't have the data types of A and B set here, but I do have the data type, say I say that it returns a number, okay? Or I say it returns a string, right? Now what happens is that you get an error here is that string is not assignable to type number. So how do we define what data type is the function going to return? We go and do this thing. We write the type notation just like we do with variables using the same Pascal notation, write colon and then write the data type, and we do it just after the brackets of the function. We write here string colon string, which means that the function is going to return a string. Now if I am creating just an empty function, let's say function say hello, and I write return hello, right? Now if I try to write something like this, say z equal to say hello, so I get an error here because I have not really written whether say hello is going to return a string or boolean or whatever, but TypeScript can check constants like this hello, and it knows that the function say hello is going to return a string because that's the only data type that it can return, because it's hard coded to hello and hello is a string. So TypeScript is going to prevent you from using say hello because TypeScript has figured out that this function returns a string. So I don't need to go and write string here because TypeScript has been able to figure out from the constant out there. Okay, in the in the case of a plus b, it was not able to figure that out because it depends on the variables that we send. If we send two integers, it's gonna give me back an integer. If I send a number and a string, then it's going to return me a string because number plus string creates a string in JavaScript, right? So it depends whether TypeScript is able to understand from the return statement in the function what the function is going to return, and then it will automatically assume the return type of the function. Otherwise, you'll have to like write the return type, specify that like this. Okay. Okay. So let's like just set this to something like you know y equal to say hello, and now it's all fine because y was supposed to be a string anyway in the beginning, so I can set the value of say hello into y. Okay.